Because I couldn't upload all of the code to the presentation, the PowerPoint presentation, I've just included a video of me going through the code and kind of explaining what's going on and why I wrote what I wrote. So we include the libraries for the keypad, the liquid crystal display, and the servo. Um, we set up the servo. We set up the thing for um, the accelerometer. We initialize the accelerometer as we did in one of the labs. The temperature, X gyro, Y gyro, and Z gyro really aren't needed. Neither the Z acceleration or X acceleration, but because we used it in the lab, I included it just because I knew that it worked in the lab. I know it will work here. Um, and it really didn't take up too much space. And I didn't really know in the beginning if I was going to be using the other things. I didn't end up using them as I didn't need them. Um, and then we set up the liquid crystal display here. Here we have a string that is locked or unlocked. We have a string enter. We have a tally that tells us how many attempts how many wrong attempts we've had. Um, we have the initial code, which is given, which is 1, 2, 3, 4. We have a string that holds the new code that's entered by the user. And then right here, we set up the keypad as what we wanted. Um, and then we have the whole setup for reading all the data from the accelerometer. And yes, we didn't end up using all the data that it gives us, but it was good to have it in the beginning. And I didn't end up getting rid of it because I might end up adding on to this project later and might end up using different values later just to experiment a little bit. Um, and here we have a constant integer, which is the buzzer. So we have the buzzer is set to pin 13. And then we have bool is unlocked and it equals false. So this just tells us whether or not it's unlocked, and this is important for later. Um, Here we set up the keypad a bit, setting where and how it's going to be managed, and which buttons are going to go to which rows and columns as set up earlier. So we're kind of defining that a little bit more there. And then we get to the setup. So we kind of set up the accelerometer. We start our serial monitor. This way I could troubleshoot things and I could calibrate the accelerometer to the right values later on. We start the LCD. We set the cursor to the second row, first column, and we write whether it's locked or unlocked, and it should be locked. As right here, it says locked. That's how it starts up. And it starts in the locked position, as right here. It sets the cursor to the first row, first column, and it says enter code. And then it attaches the servo at the pin 10, and it turns the servo to the lock degree, which is this 90 here. And then we have the loop function, and here we set the LCD cursor to the second row, first column, and we clear it. And then we go back to the second row, first column, and we write locked or unlocked. And then we go to the first column, first row, and we clear it. And then we go again to the first row, first column, and we write enter code. And then after that, we write our enter string, which is what has been entered. And then we read the accelerometer data, and it delays every 1,000 milliseconds or 100 milliseconds. And then if y acceleration is greater than this, it turns on the buzzer, and if it's less than this, it turns on the buzzer. And this is so, and this was for the demonstration, this 1,000, and that's how long we ended up running it for. That's changed, and that can change, but it works pretty well. So this is pretty tight. pretty tight around what it sits at normally when it's just sitting still. And this makes it very, very sensitive to any sort of change. So if you're walking away with the safe, it would be buzzing the whole time because that Y acceleration is always changing. Unless it is sitting perfectly flat, it's going to be buzzing. And that's what I wanted. And obviously opening the door isn't going to mess with that. And shutting the door isn't going to mess with that. And then here, we read the string key and we get that key here. And if that key is not nothing, and if that key is not a C, and if that key is not B, and if that key is not the hashtag, and if that key is not the star value, which clears everything, then we get that key and we add it to enter. So that's the enter, enter plus key. And then if the key length is greater than 4, we clear everything on the LCD in those 4 spaces after the word enter code that we previously wrote here, enter code. There's the rest of the LCD screen on that row, and we clear all of that. So you see all this is clearing in the first row, which is represented by this 0, and the second number within these coordinates. And then we also clear enter, so our enter variable becomes nothing. And that's important. And then if the key is equal to the star, then enter equals nothing. And that's to clear everything. And if the key equals the hashtag or the pound key, then tally equals tally plus 1. And that's important. So it's counting how many times you've pressed the enter. But if the enter equals the code, then it sets the cursor to the second row of the second row of in the first column, and it clears that whole row. There's 16 spaces here, and then it sets the cursor to the beginning of the second row again, and it makes that LU string equal unlocked, and then the LCD prints that unlocked. And then it sets the cursor again, and then the servo goes to the unlocked position. Unlocked equals true, and that's important for later, and then tally equals 0. So we don't want we want the tally to go back to 0 if they put in the right pin. So that's why this resets back to 0 right here. And then if tally is greater than or equal to 3, the tone buzzer goes off, and it goes off indefinitely. And if tally is less than 3, then no tone, so the buzzer is just off. And then if the key equals C, it delays a second, and this is 1000 milliseconds. It delays 1 second, that way it gives the user enough time to have the door shut, and then it closes. And then the servo writes to the 90, which is the close locked position, and then it sets the cursor to the second row, and it clears it. It sets the cursor to the beginning of the second row again, and then it writes locked, and then it sets the cursor again, and then unlocked equals false because now it is locked. So it fixes that string. And then if the key equals B, then and if the key equals B, and if it's unlocked, so this is important because we want the key equal to B, and that is so that the user can reprogram. So we're pressing B, and the system checks to see if it's unlocked, and if it is, then now we can reprogram. So then it changes the LCD screen, so it changes the first row to say new code. So it clears the first row, it sets the cursor back to the first row, first column, and it says new code. And then this is a while loop that has a lot contained in it, and it says while unlocked equals true, it's going to be reading the keypad, what's getting pressed on the keypad, and basically this is the same as before. Um, so if the key is not nothing, if the key is not C, if the key is not B, if the key is not the hashtag, if the key is not the star, then it's going to read that key. And if the new code is greater than 4, then it clears everything, just as it did before, because we don't want the pin to be greater than 4. And then all that's in the while loop. And our most of that is in the while loop. I shouldn't say all of that, because if the key equals a star, this is continuing in the while loop. If the key equals star, then it clears everything. If the key equals the hashtag, then if new code is greater, so this is basically saying if you press enter and the code isn't 4, this right here, if the code isn't 4, then it's not going to do anything. But if the code is 4, so if it's greater than 3 but less than 5, which would be 4, so if it is 4, then the code equals the new code. And then unlocked equals false, and then my servo, so then it locks the servo, and then it sets the cursor to the second row, it clears the second row, it sets the cursor back to the beginning of the second row, it writes the word locked, and then it prints the L/U. I meant to say that L_U equals locked, and then the LCD prints that. And then enter equals nothing, and then the whole thing is running in this section again until the B is pressed. Where is that? Until the B is pressed, as we talked about. I hope this explains the code to you guys, and you guys can see in the video that I've uploaded later that everything is working properly. I understand that there are a few things in here that I didn't end up using, but again, they're in here because I want to work on this a little bit more in the future, and it will be fun to have those values to be able to expand upon later. And in the beginning, I didn't know which values I was going to end up using. There was a lot of trial and error, so I included a little bit more than what I needed, but all in all, it all worked out really well. And this is the code, and my name is Louis Kowalik, and hope you enjoyed.